Unified Data Platform: How Trusted Data Becomes the Foundation for AI, Analytics, Automation, and Business Transformation. Hello and welcome. Today we are going to take a deep look at unified data platforms and why they are becoming one of the most important foundations for modern enterprises. Most organizations do not suffer from a lack of data. They suffer from scattered data, duplicated data, inconsistent definitions, weak ownership, and unclear governance. A unified data platform solves this by creating a shared foundation where data can be discovered, governed, secured, refined, reused, and consumed by analytics, business intelligence, automation, and AI systems with confidence.
The core challenge is that data has grown faster than operating models. Customer data may live in CRM systems, financial data in ERP platforms, operational data in databases, collaboration content in Microsoft 365, product data in telemetry systems, and historical data in cloud storage. Each team may define metrics differently, clean data differently, and protect data differently. This creates a business problem, not just a technical problem, because leaders cannot make confident decisions when reports disagree, and AI systems cannot provide trustworthy answers when their grounding data is fragmented. A unified data platform does not mean replacing every existing system. That is one of the biggest misunderstandings. The goal is not a risky migration where all data is forced into one physical location overnight. The goal is to create a governed convergence layer where existing data sources can be connected, mirrored, virtualized, cataloged, protected, and transformed into trusted data products. The attached Microsoft Cloud Adoption Framework guidance explains this approach using Microsoft Fabric, OneLake, Microsoft Purview, Azure, Power BI, Microsoft Foundry, Copilot Studio, and Microsoft 365 Copilot as connected parts of a unified foundation for AI and analytics. At the center of the approach is the idea of data products. A data product is not just a table, a dashboard, or a file. It is a reusable data asset with business meaning, ownership, quality expectations, security classification, metadata, refresh rules, and a clear audience. For example, a customer profitability data product should explain which customers are included, how revenue is calculated, how costs are allocated, who owns the definition, how often the data refreshes, and which teams are allowed to use it. This product mindset is what turns raw data into a reusable enterprise capability. Data products need ownership, and ownership usually works best through data domains. A data domain is a boundary of responsibility, such as sales, finance, marketing, HR, operations, product, or customer service. Domains matter because the meaning of data is often created by the business, not by technology teams alone. Finance understands revenue recognition. Sales understands pipeline stages. HR understands workforce definitions. Operations understands process performance. A unified platform gives these domains a structured way to publish trusted data for enterprise reuse while still operating inside shared governance and security guardrails. Organizational readiness is the first step because technology cannot fix unclear accountability. Leaders should define the business goals that matter most, identify the data domains responsible for those goals, appoint accountable domain leaders, and prioritize the data products that will create measurable value. This prevents the platform from becoming a dumping ground for every possible data set. Instead, the organization starts with high-value products that support decisions, reporting, automation, AI grounding, compliance, and operational improvement. The attached guidance strongly emphasizes starting with business value rather than unplanned technical activity. Prioritization is critical because no organization can unify everything at once. A strong roadmap balances urgency, foundational value, dependencies, quick wins, and long-term strategic importance. Some products may deliver fast value, such as an executive sales dashboard or customer support analytics dataset. Others may take longer but become foundational, such as a master customer profile, standardized product catalog, or enterprise financial actuals model. The best roadmap includes both. Quick wins build confidence, while foundational data products create durable reuse across many future analytics and AI use cases. Microsoft Fabric provides the platform layer for building this unified data foundation. Fabric combines capabilities for data engineering, data factory, data warehouse, data science, real-time intelligence, databases, and Power BI under one SaaS-oriented analytics experience. OneLake acts as the logical data lake for Fabric, allowing data assets to be stored, accessed, and reused across workloads. This matters because teams can reduce tool fragmentation, simplify governance, and create a common storage and consumption pattern for analytics and AI without forcing every team to abandon existing investments immediately. OneLake is important because it helps create one logical place for analytics data across the organization. Data may still originate from many systems, but OneLake becomes the common foundation where trusted data products can be refined and consumed. Fabric shortcuts can provide virtual access to external data without copying it, while mirroring can selectively replicate operational data when performance, isolation, or near real-time access is needed. This gives organizations flexibility. They can start by connecting important sources, then gradually refine their architecture based on business value, compliance needs, and consumption patterns. Architecture decisions determine whether the platform can scale safely. Fabric capacity decisions affect cost, performance, concurrency, and reliability. Workspace decisions affect security boundaries, ownership, operational visibility, and lifecycle management. Region decisions affect data residency, latency, and availability. Disaster recovery decisions affect continuity during outages. The attached document recommends treating these decisions as leadership and governance decisions, not isolated technical choices. A unified platform becomes successful when architecture, finance, compliance, operations, and business ownership are designed together from the beginning. Fabric capacity can be centralized, decentralized, or hybrid. A centralized model is useful when domains are early in maturity, demand is unpredictable, and the organization wants strong central control. A decentralized model is useful when a mature domain has predictable demand, critical workloads, and clear budget accountability. A hybrid model is often the most practical because smaller or newer domains can share capacity while high-value or high-risk domains receive dedicated capacity. The important principle is that capacity should match business criticality, usage patterns, cost accountability, and operational maturity. Fabric workspaces are one of the most important governance boundaries in the platform. A workspace groups assets and controls access, administration, cost visibility, and operational responsibility. A common default pattern is one workspace per data product, especially when one team owns the full pipeline. More sensitive environments may use multiple workspaces per product, separating raw, cleansed, and curated layers for stronger isolation. Smaller or low-risk products may temporarily share a workspace, but that should be intentional and documented. Every workspace should have a domain, owner, purpose, classification, and lifecycle expectation. The medallion architecture provides the processing pattern that turns raw data into trusted products. Bronze stores data as it arrives from the source, preserving original fidelity. Silver cleans, validates, standardizes, deduplicates, and aligns the data to enterprise rules. Gold packages, business-ready outputs for reporting, AI grounding, dashboards, applications, and decision support. This pattern is powerful because it separates raw truth from trusted interpretation. It also allows teams to audit where data came from, how it changed, and which version is approved for business use. Bronze is the evidence layer. It should preserve source data with minimal modification so teams can trace back to the original records when questions arise. Silver is the trust-building layer. It resolves format problems, removes duplicates, applies quality rules, standardizes identifiers, and creates consistent structures. Gold is the business value layer. It aligns to approved business definitions, certified metrics, consumption needs, and governed access. When teams skip these layers, they usually create conflicting logic, hidden assumptions, weak lineage, and fragile reports that are difficult to trust. A simple example shows why this matters. Sales transactions may arrive with inconsistent date formats, text-based amounts, duplicate order records, and mismatched store identifiers. In bronze, the records are preserved as received. In silver, the amount becomes numeric, the date follows enterprise standards, duplicates are handled, and store identifiers are aligned with reference data. In gold, the organization may publish daily revenue by region, customer profitability, demand forecast, or executive sales performance metrics. This is the journey from raw operational data to reusable business intelligence. Governance must cover the entire estate, not only the data that already entered OneLake. Microsoft Purview provides cataloging, classification, lineage sensitivity labels, compliance support, data loss prevention, and visibility across Microsoft 365, Azure, Fabric, on-premises systems, and other clouds. The attached guidance positions Purview as the system of record for data governance and security. This is important because a unified platform cannot succeed if governance begins only after data is consumed. Governance should begin with visibility into sources, ownership, classification, lineage, and policy requirements. A data catalog gives users a trusted way to find and understand data. Without a catalog, people depend on informal knowledge, old spreadsheets, personal relationships, or repeated requests to technical teams. A strong catalog describes what data exists, where it came from, who owns it, what it means, how sensitive it is, whether it is certified, and how access can be requested. This reduces duplicate work and helps users choose approved data products instead of creating new unmanaged copies. Discoverability is one of the most practical ways to scale data reuse. A business glossary is equally important because many data conflicts are definition conflicts. One department may define revenue by invoice date, another by booking date, and another by cash receipt. One team may define active customer by login activity, while another uses contract status. A shared glossary defines terms such as customer, product, employee, revenue, margin, region, churn, headcount, and service level. This helps reports, dashboards, semantic models, AI agents, and business conversations use consistent language. Without shared meaning, unified storage alone does not create unified decisions. Sensitivity labels and classification protect data according to risk. Public data, internal data, confidential data should not be handled the same way. Protective labels can enforce restrictions, while metadata labels can inform governance workflows and catalog visibility. In a unified platform, labels should flow across Microsoft 365, Fabric, Purview, Power BI, and AI consumption paths wherever possible. This matters because data does not stay in one place. It moves from source systems to lakehouses, from lakehouses to reports, from reports to exports, and from data products to AI agents. Data loss prevention policies reduce the risk of accidental exposure. DLP can detect sensitive information and warn, block, or audit risky behavior, depending on the organization's maturity and risk tolerance. A practical rollout often starts with monitoring so teams can understand real usage patterns before enforcing restrictions. Once policies are accurate, the organization can move toward blocking or restricting high-risk actions. The goal is not to stop productivity. The goal is to make safe behavior the default, especially when data products are reused across many teams and tools. Lineage is one of the most valuable governance controls because it shows how data moves and changes. If an executive dashboard number looks wrong, Lineage helps trace the metric back through gold, silver, bronze, and the original source. If a schema changes, Lineage helps identify downstream reports, models, agents, and applications that may be affected. If auditors ask how a regulated report was produced, Lineage provides evidence. In a unified data platform, Lineage should be treated as an operational control, not just documentation. It supports trust, impact analysis, compliance, and incident response. Security standards must be designed for every consumption path. Power BI, Fabric data agents, Microsoft 365 Copilot, Copilot Studio, Microsoft Foundry, Azure AI Search, and custom applications do not all enforce access in exactly the same way. A unified platform should define which access paths are approved for which data categories. For sensitive structured data, Fabric data agents can be a preferred path because Fabric applies workspace permissions, item permissions, role-level security, and column-level security. For index content, Azure AI Search and Foundry IQ require careful attention to labels, access control lists, and metadata quality. AI makes unified data governance more urgent. AI systems can retrieve, summarize, combine, and generate responses from enterprise information at high speed. If the data foundation is weak, AI can amplify wrong definitions, stale data, excessive access, and hidden duplication. This is why AI should be grounded on governed data products rather than random source extracts. Data products give AI systems a better foundation because they include ownership, quality, business meaning, access rules, and intended usage. Responsible AI begins with responsible data management. Microsoft 365 Copilot, Copilot Studio, Fabric data agents, and Foundry agents each introduce different patterns for using business data. Microsoft 365 Copilot works within the user's existing Microsoft 365 permissions. Fabric data agents can expose governed Fabric data while respecting Fabric security. Azure AI Search can power retrieval, But index content must be secured carefully because indexes can become new exposure points. Foundry agents can connect to tools, indexes, Fabric data agents, and external systems, which means organizations need clear approval rules for which connectors are allowed and which scenarios require review. A unified data platform should include a business data in AI standard. This standard should define which AI tools are approved, how prompts and outputs are handled, whether business data can be used, which services remain inside enterprise boundaries, and how sensitive data is protected. Teams should treat prompts as business records when they contain business information. AI agents that access sensitive systems or perform actions should require stronger review than simple read-only experiments. The standard should enable innovation, but it should not allow uncontrolled tools to become hidden data pipelines. Cost governance is essential because unified platforms can create value and cost at the same time. Fabric capacity, OneLake storage, mirroring, Power BI usage, Purview governance, Databricks integration, Azure AI search indexing, and AI workloads all have cost implications. Leaders should set domain budgets, approve capacity assignment, review utilization, control scaling, monitor surge patterns, and connect spending to business outcomes. The goal is not simply to reduce cost, the goal is to spend intentionally on the data products and workloads that matter most. Operational standards keep the platform reliable after launch. Teams need rules for ingestion, transformation, publication, consumption, monitoring, change management, and retirement. Data should enter OneLake only when it supports a business outcome or approved data product. Transformations should follow agreed platform boundaries so the same logic is not duplicated across systems. Published products should include metadata, ownership, classification, intended use, refresh expectations, and endorsement level. Consumers should know which products are official and which are experimental. These standards prevent the platform from drifting into uncontrolled complexity. Monitoring should cover technical health and business trust. Technical monitoring includes capacity utilization, refresh failures, pipeline errors, query performance, job failures, and throttling. Business trust monitoring includes data quality issues, stale products, usage patterns, access reviews, and downstream impact. Critical data products need stronger monitoring than exploratory products. A customer-facing AI agent or executive financial dashboard deserves stricter oversight than a temporary internal analysis dataset. Monitoring should be scaled by business criticality so the organization protects what matters most without overburdening every small experiment. Change management protects consumers from surprise disruption. When a data product changes, downstream reports, semantic models, applications, and AI agents may be affected. Breaking schema changes, metric changes, refresh changes, and access changes should be communicated before they happen. Teams should use lineage and impact analysis to identify affected users and systems. Change notes should be recorded in the catalog, and consumers should receive clear guidance about what is changing, when it will happen, why it matters, and whether they need to update anything. This discipline creates confidence in shared data products. Retirement is also part of governance. Data products should not live forever just because they once had value. Outdated products create confusion, duplicate logic, and unnecessary cost. A retirement standard should remove endorsement, notify consumers, preserve metadata and lineage for audit, define a timeline, and provide replacement guidance if needed. Some products can retire quickly when there are few dependencies. Others need a longer transition because many reports, models, or business processes depend on them. Controlled retirement keeps the platform clean, understandable, and trustworthy. A unified data platform can still include specialized platforms such as Azure Databricks, Azure Machine Learning, or existing data lakes. The key is to integrate them through governed patterns. Databricks may remain valuable for large-scale data engineering, advanced machine learning, or teams with established Spark expertise. Existing ADLs, Amazon S3, or Google Cloud storage environments may continue to hold important data. The unified platform should not reject these investments. It should expose trusted outputs through OneLake shortcuts, mirroring, catalog registration, lineage, and Purview governance so the enterprise sees one governed data state. The relationship between Fabric and Databricks should be intentional. In some cases, OneLake can become the system of record, and Databricks can read from and write to OneLake. In other cases, AWS remains the system of record, and Fabric accesses curated datasets through shortcuts. The right choice depends on existing maturity, pipeline complexity, governance goals, performance needs, and migration risk. A mature Databricks estate may not need immediate refactoring. A new platform build may benefit from making OneLake the primary governed storage layer from the start. Region, residency, and recovery decisions should be made early. Organizations operating in multiple geographies may need formal rules about where data and compute reside. Regulated data may require specific residency controls. Critical workloads may need disaster recovery because downtime creates material risk. Exploratory products may not justify the same cost. A mature platform publishes supported regions, defines when multi-geo is required, explains recovery expectations, and aligns business continuity decisions with workload criticality. This avoids inconsistent regional decisions that create compliance and operational problems later. The people model is as important as the platform model. Domains need the right mix of business leadership, data engineering, analytics, governance, security, and operational skills. Some domains may need dedicated teams because speed, context, and business impact are high. Others may share central services because skills are scarce or demand is variable. A hybrid staffing model is often realistic. Central teams define standards, reusable patterns, enablement, and guardrails, while domain teams own the meaning, quality, and lifecycle of their products. This balance supports both consistency and accountability. Training and skills development should be connected to active delivery. Courses and certifications help, but real maturity comes when teams apply learning to real data products. Analysts need to understand certified data sets and semantic models. Engineers need to understand fabric pipelines, lakehouses, warehouses, and delta tables. Architects need to understand landing zones, capacity, security, networking, and integration patterns. Governance teams need to understand purview, labels, lineage, catalog workflows, and compliance monitoring. AI teams need to understand access models, grounding patterns, responsible AI, and data protection. A good implementation approach starts small, but designs for scale. The first wave should focus on a few high-value data products, clear domain ownership, basic cataloging, sensitivity labels, workspace standards, capacity monitoring, and one or two priority consumption paths, such as Power BI and AI grounding. The second wave can expand domains, improve lineage, add certification, strengthen DLP, formalize CI/CD, and integrate more sources. Later waves can mature automation, cross-domain reuse, AI agents, advanced monitoring, cost optimization, and retirement processes. This staged approach reduces risk while building momentum. The biggest risks are not only technical. One risk is creating a beautiful platform with no business ownership. Another risk is ingesting too much data without clear purpose. Another risk is allowing every team to create its own workspace, pipeline, glossary, and metric definitions without standards. Another risk is treating AI as separate from governance. Another risk is delaying security until after data products are already widely consumed. The safest path is to combine value-driven prioritization, domain accountability, governed architecture, security by design, and operational discipline from the beginning. The business outcomes can be significant when the model is done well. Leaders get more consistent metrics. Analysts spend less time searching and cleaning data. Engineers reduce duplicated pipelines. Compliance teams gain better visibility. Security teams apply policies more consistently. AI teams can ground agents and models on trusted products. Business users can discover approved data without relying on informal networks. Over time, the organization shifts from project-by-project data delivery to reusable data capability. That is the real promise of a unified data platform. In practical terms, the platform becomes the bridge between operational systems and intelligent experiences. Source systems continue to run the business. Fabric and OneLake unify analytics data. Purview governs visibility, classification, lineage, and compliance. Power BI delivers dashboards and semantic models. Fabric data agents, Foundry, Copilot Studio, and Microsoft 365 Copilot help users and agents interact with trusted information. Azure and Databricks support specialized workloads where needed. The result is not one tool replacing everything. The result is an ecosystem operating around shared trust, shared meaning, and shared controls. The final message is that AI transformation depends on data transformation, and data transformation depends on operating model transformation. A unified data platform is not just a technology stack. It is a management system for turning scattered information into trusted data products that people, reports, applications, and AI systems can safely reuse. Microsoft Fabric, OneLake, Microsoft Purview, Power BI, Azure, Foundry, and Copilot experiences provide the technical building blocks, but success comes from ownership, governance, security, quality, cost discipline, and continuous operations.
Thank you for watching, and I hope this helped you understand how a unified data platform becomes the foundation for trusted analytics and enterprise AI.